Okay, I am very sorry that this is just going to be a regular recording. I forgot my iPad at work, but I wanted to get these video notes to you guys since I won't be there tomorrow. So um, this is just a review of how you simplify radicals. And since complex numbers have this imaginary part to them right here, they technically fall into the realm of having at least a portion of them that will have radicals that have to be simplified. So what the steps remind you of is it says to remember that anytime you have a negative inside of a radical, that it's going to become imaginary. Now the steps here are just one way of simplifying radicals. It says find the prime factorization. I'll do those for you, but I'm also going to show you the other way to simplify these radicals. Because if you do the prime factorization, then you have to break everything down as far as you can, which is more time consuming because what you're looking for is the same factor to pull out multiple times. So I'll show you both ways so that you can do it your choice. And it says that anytime you have a bunch of factors that are going to show up in front of your radical, you need to multiply those back together, because remember, you will have just factored these numbers. And then you also want to multiply the factors under the square root back together. And so I'll show you what that looks like. So here's our first example. It says the square root of negative 81. So according to the steps, what it's saying to do is it's saying to take this negative that's inside the radical and move it outside the radical by writing it as I. And then it's saying to split this 81 up as its prime factors. So it's saying take it and split it up as 9 times 9. And that way it's saying now you can take that pair of 9s and pull it out of the square root, and it just becomes 9i. And that's perfectly fine, that's correct. But this whole notion of having 2 inside and when you pull it out it becomes a single thing, it can confuse some people. And of course the more complicated the number, the more factors you're going to have inside of here. So we're going to work these problems multiple ways for at least a little while until you guys can choose which way you do this. But the answer for the square root of negative 81 is 9i because the square root of 81 is 9 and the square root of negative 1 is I. Okay, so now if I tried this radical, I'm going to try it a new way so you can see a second way. So instead of having people break this down as all of its prime factors, because that would start out by pulling out a 2, and then you'd be left with the 49, and then you'd pull out the 7 inside and pull out another 7. And so instead of breaking it down with your upside down factor tree, or what they called upside down division, what I just have people do is I start figuring out what is the biggest perfect square that goes into it. So I look at numbers like 98 and I know, okay, well, 25 is not going to go into it. 25 is a perfect square. Does 16 go into it? You know, things like that. Perfect squares. And you find the biggest one that goes in. And the biggest one that goes in is 49. And so what I would do is I would split it up as the 49 and the 2. And now 49 has a perfect square root, which means you can go ahead and pull it out and take its square root, and you just get 7 square root of 2. And so that is the simplified version of that radical. Okay, so what I want you guys to do is I want you to take a second, and I want you to try these two. C is more closely related to A, and of course D is closer to B. So take just a quick second and see if you can at least get them started. Okay, so hopefully you paused the video. I took a second and tried those problems. If not, pause it now so you can give those a shot. But what I would do here is remember that when you take that negative and you pull it out, it becomes an I. And 144 is a perfect square, and so it gets pulled out and it becomes a 12. Now what you need to remember though is that all this stuff outside the radical is being multiplied together, so it becomes a 36i. And so there's your simplified radical. So then this one, 75, is not a perfect square. That's why it's closer to b than the other version. So I've got the negative out front. The negative inside that square root pulls out and it becomes an I. And then I figure out what numbers go into 75, and I find the one that's the biggest perfect square. And so I would break that one down as the square root of 25 times 3. And so now I can take that 25 and I can take its square root. And I pull it out, and it moves out there with the negative and the I, and becomes a 5, of course. And then I leave the 3 inside the radical. And so there's that simplified radical. Okay? So these are just some practice problems for you guys to try here. They're very similar to the ones we just did. I do want to at least address a couple of these fractions as well, just because people think that fractions work differently than other numbers, but they really don't. So what you do is you treat each part of this fraction as if it's its own square root. And you reduce first. I mean, you always want to reduce first. So, I mean, there's at least 3 different directions I could go with this problem, but what I'm going to do is this. The first thing I'm going to do is go ahead and deal with the negative, because no matter what I do inside, that negative's not going to go anywhere. It's not going to reduce. So I'm going to go ahead and pull it out, and I'm going to make it an I. And then 45 and 36. So this is 9 times 5, and this is 9 times 6. Now I can reduce it, so I'm showing you one direction that I'm going with this. But